This demo is about experiment number 3 regarding study of the capacitance and capacitive reactance of a capacitor. In this experiment, shall need to have a voltage supply alternating lab work guide. This shall be set to a peak value of to be set at kilohertz. For the trial one, we shall set frequency 200 low, say pure C. For this run, shall set the capacitance to 50 microfarad. Use the switch. I'll include the switch. Copy this for the other capacitors. This for run 2. And I'll set these to 60 micro. Is 20 micro. Meters, ammeter to voltage. I'll set this period the ground. And can now run the circuit for the run 1 first trial. We shall close this switch S1 and C1 is connected to the 15 volts peak value. This is with a frequency of 500. We can see that is a 1.67 ampere and 10.607 volts. The voltage across the supply. The voltage supplied is also the voltage across the capacitor, since there's no other element in the circuit, and we can check that by adding another voltmeter and see that these two voltmeters same value voltage. And we can see that the VRMS supplied is 10.607 and the voltage across the capacitor is 10. So for run 1, we shall register this to the table 3.1. This is at 500 hertz. Current is 1.67. amperes, and the voltage is 10.607. Is 10.607 volts and 1.67 amperes. Now to calculate for this X sub C. So X sub C for this trial is equals to 10.607 divided by 1.67, and that is the capacitive reactance of the capacitor. This is equals to 6.351 ohms. Now the capacitance connected in the circuit is actually 50 microfarad, but we can verify this using the formula. Capacitance equals to 1 over 2 pi f X sub C, and calculate for the capacitance based from the calculated value of reactance. This would be 2 pi. This is 500. The X sub C is 6.351. This is equals to 50.1150 farad. is actually approximately equals to the value of the capacitance connected. Some discrepancy, probably decimal portion. We have truncated some values from the voltage and also from the current. Of course, it will affect the value. Is a difference from 57 farad, discrepancy insignificant. So for your experiment, you will change the frequency to 600 and increase it up to 1.2 kHz and observe the reading of the meter and the reading of the ammeter. Calculate for the X sub C trial, verify the value. So here we shall increase this to 600. Let's run the circuit and let's observe how the values of the voltage current would change to increase frequency of the supply from 500 to 600. As you can see, the value of current increase, but the voltage supply is the same. At 600 hertz, the current is 2. And for this reading of the reading in table 3 and necessary values for capacitive reactance capacity. Now, for run 2 shall set the frequency to little bit lower. Is at frequency of 100 Hz, the same peak value supply. Shall set these two So from this setting, we shall connect 3 capacitors in the circuit, 1 capacitor at a time. So capacitor at a time. And observe the reading of the current goes into the circuit as we change the capacitance value connected in this. So this is a variation the value capacitance of the circuit. Let's run. Here, the current is 334.20. Voltage is 10.07. So the voltage is maintained. And for run 2. This is the table for run 2, table 3. And official record, the same voltage, it is 10.607. Volts, while the current is current registered ammeter is 334.29 milliampere. 334, or this is 0.334 ampere, and therefore the X sub C is 10.607 over 0.334. We have here a reactance of 31.70 ohms. So we can verify the value of the capacitance. Again, this formula, which is 2 pi, frequency is 100, and the XP is 31.75. So this is 31.75 ohms. Then equals to 50.11 microfarad. And then for trial 2, trial 3, we shall simply increase the number of capacitance connected circuit. And that is by closing the switch. Observe the reading of the ammeter. Close the switch S. It has increased to 730. And then close, increase the number of capacitor circuit. We close S3. Now for the calculation of the total capacitance, the formula for capacitors in parallel, we simply add the value of the capacitance connected in parallel to get the total capacitance. While if capacitors are connected in series, we apply formula similar to parallel resistors that for capacitors in series, connected in series, it would decrease the value, the total value of the capacitance in the circuit. For series, the C total is calculated as 1 over C1, 1 over C2 plus 1 over C3, and so on. That is for capacitor. In series. In connecting capacitor in series, you have to take into consideration the terminal of having the same polarity. For parallel, the C total is simply C1, C2 plus C3 plus so on. There are more than 3 capacitors connected parallel. This means that as we connect more capacitors in parallel, it increases the capacitance. Why? Because capacitance is directly proportional to the area of the plate and inversely proportional with the dielectric or the distance between the plates. So capacitors, the gap between these two plates are conducting material, and the space between is dielectric, meaning you may place insulators between the conducting material, or simply a space, and the space between these plates, the gap is considered as insulating material. So as you increase the area of the plate, you increases the capacitance. Now if you connect the capacitors in series, you are increasing the dielectric, which is inversely proportional with the capacitance. Thus, increasing the dielectric would decrease the value of the capacitance in the circuit. Your experiment, you connect capacitors parallel, or we expect an increase in the capacitance, you increase the number of capacitors in the circuit. So this is your experiment 3 in the study of the behavior of the capacitor, capacitive reactance, and capacitance in a circuit.